Okay, so as we use a pedigree to assign genotypes, because that's really what genetic counselors do. It's just circles and squares and lines if you don't know how to interpret it. So what we have here is a family history for this couple, male and female. The little triangle, or the little sort of rhombus diamond-shaped thing down in the middle with a question mark, that's a potential future offspring. So they're coming to a genetic counselor because either they're already pregnant and they're concerned about something, or they're considering becoming pregnant, and so they're coming in to talk. We don't know what this condition is. Could be anything. I told the other class, in biology we used to teach a lot of things as being Mendelian traits. So we taught widow's peak. That's if your hair comes down to a point in the middle of your forehead. We said that was Mendelian. Connected earlobes were supposed to be Mendelian. Whether or not you could roll your tongue was Mendelian. That's all a bunch of hooey. They're polygenic. Most traits are polygenic. There are very few true Mendelian traits in humans. Earwax is one of them. And a lot of disease conditions, like the ones we're looking at, are also Mendelian. But most characteristics in humans are polygenic, meaning there are multiple genes that control that trait, like eye color. Not even close to monogenic, not even close to Mendelian. So we don't know what this condition is. It could be earwax, it could be cystic fibrosis, it could be PKU. We don't know, but we have a family history for this couple. And the alleles for this are big N, little n, sort of the generic ones we use when we don't know what the condition is. So the possible genotypes for anybody on this page would be big N, big N, big N, little n, little n, little n. I'll move those over there. Those are the only three genotypes we could have. So the first question is there anybody on this page whose genotype you can immediately identify? Raise your hand if you think there is. Okay.
The maternal grandparent and...
Okay, just one. Okay, just one. So the maternal grandfather?
Yeah.
And what would his genotype be? Little n, little n.
Yeah.
Why do you know that?
Because there's other parents that are having affected children, so this is obviously recessive.
Well, we know it's recessive. I told you that. But how do you know that that's his genotype? You're right. You're right that is his genotype, but how do we know it's his genotype? So who wants to fill that in?
Because it's circled in black and then as affected.
He's affected. If this is a recessive condition, in order to be affected, you have to get 2 copies of the recessive allele. So we know that he is a little n, little n. He is homozygous recessive because he's affected. So who else in this diagram can we immediately identify their genotype? Give me one, Daniel. Which one? This one?
Yeah.
Yes. Okay, so you're saying that this person, we can immediately identify her genotype, and what would it be? She's also little n, because she's affected. So who else can we identify? Okay, those 2 offspring in generation 3, the brother and sister, would also be little n, little n. Whoops, that's not what I wanted. Copy, paste. Okay, well that gets us to our next question. So this is kind of the low-hanging fruit part of it. When we have a pedigree for something that we know is recessive, we know it's autosomal, meaning it's carried on which chromosomes? First 22 pairs, so the first 44 chromosomes. When we have an autosomal recessive, we know anybody who's affected is a homozygous recessive. We can label those immediately. And this is like going through a math test and picking out the easy problems and doing those first. Do the easy bit first. Find all your affected individuals and immediately label their genotypes. So, is there anybody else whose genotype we know for sure? Whose parents? Okay. This lady claims that we automatically know the genotypes of the parents of affected offspring? Who agrees? I do. Okay, Nathan. Either Nathan. I'm pointing in a direct line, and I can point at both Nathans. Okay, what is the genotype of the parent of an affected offspring?
They're both carriers.
They are both carriers. They are
Both little n, big N.
big N, little n. Yes. So we know that these parents, whoops, wrong color, are both big N, little n. They are carriers, or they couldn't have affected children. Who else is a carrier? The other parent of an affected offspring. So we know that this lady is a carrier. Is there anybody else we know is a carrier? 100%?
The grandparents would have to be in
Do they have any affected offspring? So not necessarily. They could be, but we don't know that they are for sure. We know one of them has to be. There's one other person in this who right now we can positively say is a carrier. Who do you think, Daniel? Okay, the granddaughter's father. Yeah, he has to be a carrier. Who do you think?
The other twin.
The other twin! I put in the identical twins for you, Delaney. You didn't even catch that. Oh, shoot. I'm sorry. You know what? I drew that wrong. I screwed that up. Let me fix that. I apologize. Yep, that's why you didn't catch it, because I drew it wrong. There. Now, would you say that you could identify them as identical twins? Okay. So we know that the identical twin must also be a carrier. Does that tell us anything about anybody else? Is there anybody else who we can positively identify? The client, the female client?
Because wouldn't she have to be a carrier because her dad?
Yes. So, you left ahead a couple steps. Let's look at the client, the female client here. We don't know what her mother's genotype was. Her mother could be big N, little n. We don't know. We can't positively identify her mom's genotype. But we know her dad's genotype because he's affected. So if we look at her parents, and we do a Punnett square, and we just leave that blank because we don't know what her mother's contribution was, we would have big N, big N, little n, something, little n, something, little n. Guess what? Chances that she's a carrier? 100%. No matter what, she got a recessive allele from her father. He had nothing else to provide her with. He had no big N to give. So we know for a fact that she has to be a carrier. How do we know she's not affected? She's not colored in. Yeah, she's telling us that she is not affected. So she has to be big N, little n. It's for sure. Now, what about her husband, or prospective husband, or whatever he is? Do we know anything about his genotype? Do we know what the can we rule out any genotypes for him? Yeah, we can rule out little n. We know he's not affected, so we know he's either big N, or big N, little n. Those are the two possibilities for him. What do we know about, do we know anything about his parents' genotypes? Well, one of them has to be a carrier. Why?
Because they're grandchildren.
Because they have grandchildren. Their children, we know at least the twins have to be carriers because one of the twins had an affected children. So we know one of them is a carrier. We don't know which one. They could both be carriers for all we know, and they got lucky. It could be that one of them is big N. We don't know. We don't have any certainty on that. But what we do know is, what are the chances of him being a carrier? Do we know?
I would say pretty high.
Well, we don't know. And I'm gonna say, Mr. Professional Genetic Counselor, we don't say pretty high. When we ask for chances, we want numbers. You have a 1 in 4 chance. You have a 2 in 4 chance. You have a 3 in 1 in 3 chance. So that's fine. In the last class, I had to say that, we don't write a letter to our client saying, sorry, dude, tough luck. So we're going to work on the professional language, and we're going to use, yes, you cannot write to the client and say, sorry, dude, tough luck, looks like you're a carrier. So there are cases where we cannot determine genotype. And this is one of them. For the husband, we can't determine genotype. What are his odds of being a carrier? We can't even come up with a single number for that. Why not?
You have no idea what either of his parents are.
We know at least one genotype of his parents. For the other genotype, it could be one of 2 possibilities. So we can't come up with a number. We know he isn't affected. That's a case where a genetic counselor explains that we cannot determine the genotype of your parents. We would recommend genetic counseling. Now, in the work that you're going to do, you are going to do all this work and try to figure out if somebody's a carrier or not. And then here's the nice part. In this day and age, guess what? We have a lot of genetic tests available. I mentioned that I was tested for CF when I was pregnant with my daughter. These days they test, because the testing has gotten easier and easier, they test for a whole range of genetic conditions, usually when a woman first becomes pregnant, and if not then, if you have a known family history of some risky condition, you may ask for testing before you decide to get pregnant. It may be something that's dangerous enough, horrible enough that you decide you don't want to take a chance bringing a kid into the world who's going to suffer a whole lot. So how many, 0 to 5 scale. 0, I'm not sure what a genotype is. What's a pedigree? Who are you? Why am I here? 5, I can go through my entire pedigree and assign all the possible genotypes and figure out all the percentage chances right now. Let me go. Where are you? 0 to 5. Hold up fingers. You can be subtle. I got some 3s, I got some 5s, I got some 3s. Okay, here's what we're going to do. We're going to split. If you are a 5, you think you can fly solo, start working on assigning genotypes to the individuals in your autosomal recessive pedigree. Do not do the X-linked yet. It's a different system. But go ahead, and if you feel like you're ready to fly, fly, little birdies. If you feel like you need a little bit more practice, we're going to do one more together, okay? Okay, so what do we have here? We have another pedigree. We are showing 2 separate adoptions here. So I went through, I think I told you guys yesterday, I looked up the article from the National Association of Geneticists and their discussion about standardizing representations of lines of inheritance. I should make this one simpler to start with, I guess. So the brackets around an individual mean that they are adopted. The dashed line of descent shows that they were raised by this couple. The solid line of descent, the biological line of descent, is coming from the mother. In this case, we don't know anything about the father, so we don't show him. He's apparently unknown. We may not even have much information about the mother. So in some cases, people do get genetic information about their birth parents with an adoption. In some cases, they do not. It depends. Okay, and then we have, so who can tell me, if you're still following along, if you're not flying solo, what's the case with this family? How did they get their family all there together? Who'd they adopt? They adopted all 3 children.
They adopted the one with sickness by himself and the other 2 together.
Yes. One was a child who had no siblings who were up for adoption, or who was who was a singleton adoption. The other 2 were biological siblings who were adopted together. And that's fairly common these days. They try to keep biological siblings together when they can, in the case of adoption. Okay. So now that we've figured out that, what do we know about genotypes here? Is there anybody who's a genotype we can immediately identify? Daniel. All the affected individuals. And this is autosomal recessive. What's the affected individual's genotype? Yeah, and we were using N, but that's okay. You can use whatever you want. So we've got 3 possibilities for genotype, and we know that all the affected individuals, this is a recessive condition, so they have to be, whoops, little n, little n. Now, for the husband, for our client, he has an affected sibling. Does that mean anything about him genetically? No, because it's a sibling by adoption. So just because of the sibling, we can't determine anything about him. There are, for people who have sort of what we'll call complicated family histories, they might have, I've known families where they had multiple siblings who were adopted from multiple biological parents. So they might have biological siblings, but it might not give you any information. We don't have any genetic information about his parents. Can we say anything about his genotype? Nope. We can rule out one genotype for him. What can we rule out? Yeah. He is not, we know he's not a recessive homozygous, so we know he's either big N, little n, or big N, big N. And we don't know. To get any clarity on that, we would have to have genetic testing. Anybody else here who we can identify positively? Who, Daniel? The daughter's mom. Okay, so our client.
Yeah, the client's a carrier.
She's a carrier. She has to be a carrier because she has an affected child.
So would
Her ex-husband would also be a carrier. Yes. That's automatic. If you have now, do we know anything about her siblings? She has 2 sisters. What do you think?
would they have to be carrier too because their father?
Their father was affected. They have to be carriers. So we know that all of these ladies, these 3 sisters, are definitely carriers. Okay. We can't tell anything about these parents. And we don't, if we're just tracing a genetic disorder, we're not really worried about them because they don't have a genetic relationship to the client. We do show that dashed line of descent for adopted individuals because if we're concerned about a disease that has an environmental cause, like, it's some kind of chemical you were exposed to or the kind of food you eat or, something else, then we want to know that these people were raised by this couple and so that all those 3 adopted siblings would all share an environment growing up. But we recognize that there's not a genetic connection. There's not a biological connection. Okay. How do you feel? You guys are burning it up at labeling genotypes, I think, for the most part. I think people are pretty good at this. I will not be here tomorrow. Tomorrow, here's what you're going to have. You will be moving on to doing your research. So I would still hold off on doing your final drafts for your project. I mean, if you feel like you're all itching to go and you're antsy and you want to get there, okay, that's fine. We have not yet talked about assigning genotypes for sex-linked conditions, so do not try that one. It's a totally different system. Tomorrow, you're going to start researching on both your diseases. Here's the thing about your little professional groups here. You should be working with the people in your little professional group who are working on the same condition you are. I am leaving this rather free form. Head up, Alex. Alec, sorry, I haven't done that in a long time. So I'm not saying what form your initial research has to take, but you should produce some notes. That can be a bullet point list. That can be, your initial writing about it. It can be on paper. It can be electronic. I don't care. But a great thing to do is, Nathan and Stephen, hey, we're both working on Friedreich's ataxia. Here are 10 websites I found. Why don't you read 3 of them and I'll read 3 of them? You can share that and then you can talk to one another about what you found.
You just said there were 10 websites and I read 3, you read 3. That leaves 4 left.
Yeah, I know. There are other people. So anyway, don't worry about the math. You read some of them, I read some of them. Then we'll talk about what we each found and check our understanding. Hold. Are you finding the same things I am? Is this all reinforced? You're going to do both of your disorders. Do your preliminary research. That research should be separated. Peyton. That research does need to be separated. You've got, what, 45 minutes, let's say? You should be able to look at least 5 websites, maybe 6 websites in that time, and make some notes from each of them, because the research that you're doing is going to go into your letter to your clients. You know, that letter to the clients that says, "Dear Mr. and Mrs. Smith, you came to me based on your concern about Friedreich's ataxia and potential children, and I'd like to share with you some information about the disorder." And you're going to share information, then you're going to talk with them about their specific odds of contracting the condition. Because I have had problems with work getting done when there's a sub, and that's what led to my, if you are not listed as absent and you don't turn in whatever's assigned, you get a 0 and there are no makeups. You are going to have to show me your notes from your research when I get back on Friday. So I don't care what form it's in. Like I said, electronic, paper and pencil. Don't write it on your arm, it'll wash off. But you are going to have to show me documentation that you did that research. You can make a list, and you need to record what resources you're using so you can go back to them and so that you can cite them, because you're going to cite them for me in the project. Okay? Questions? Did I answer it?
No.
Okay.
For example, there's like a sister of the...
That's the X-linked?
This is Friedrich's text.
Okay, that's all Friedrichs. Okay.
There's the sister of the father that wants to have a child.
Sister of your client.
That is affected.
Yep.
Wouldn't that have to make the client carrier?
Nope.
Right.
Do the Punnett square and prove it to yourself. Makes his parents carriers.
Right.
Okay, other questions? Other concerns? Okay, so that's tomorrow. You're doing your research, you're documenting your research, and by the end of today hopefully you should be getting those genotypes assigned on your autosomal recessive.